Problem sheet 5, question 4. Solve the following linear program using the two-phase method. Maximize 2x1 plus 3x2 plus 4x3, subject to 3x1 plus 2x2 plus x3 is less than or equal to 10. 2x1 plus 3x2 plus 3x3 is less than or equal to 15. x1 plus x2 minus x3 is greater than or equal to 4. x1, x2, x3 are all non-negative. Okay, so now we have a mixture of less than and greater than constraints. So when we write this in standard form, we'll have to be careful of the sign of the slack variables and possibly introduce artificial variables where required. So let's write this in standard form. We have maximize this subject to and now for this constraint, it's a greater than constraint, so we have to take away the slack variable. But in order to ensure that we have enough basic variables, we also have to introduce an artificial variable. So we now want to begin the first phase of the two-phase method, which would be to minimize the sum of all the artificial variables. These artificial variables represent how infeasible we are, and if we can minimize that, ideally to 0, then we become feasible. So we only have one artificial variable, so the sum of all the artificial variables, a1, would be equal to, now we're only going to be able to minimize linear combinations of the decision variables, which is this thing. Each of those decision variables, x1, x2, x3 and s3, at the beginning are all non-basic, and so they all must be set to 0, and therefore the value of the sum of all the artificial variables currently must just be equal to 4. So from here we can write down our initial simplex tableau. Which now includes an artificial variable column and two objectives, the original objective and our objective, which is to minimize the sum of all the artificial variables. Our original objective function was to maximize, so we will put the coefficients in negative. And our current phase 1 objective is to minimize the sum of the artificial variables, so we will put those coefficients in their original sign. What is the value of this objective? Well, we know this is the sum of all the decision variables that make up the sum of the artificial variables, which currently has a value of 4, and so this must have a value currently of -4. And this is the initial simplex tableau. We are now going to perform the simplex algorithm on this, treating the newest objective, so that final row, as our objective, and we can just treat our original objective as another constraint in this first phase. So first we will look at that objective row and we'll decide on our work column. Our work column will be the one with the most negative value in the objective row. We currently have 2. We can decide on our pivot, which would be the element in those columns that when we divide the left hand side by that column gives us the least positive ratio. So 10 divided by 3, 15 divided by 2, 4 divided by 1, 10 divided by 2, 15 divided by 3, 4 divided by 1. So the smallest positive ratio will be 10 divided by 3, and so that is our pivot. Now we need to decide on our row operations, which will make this work column 1, 0, 0, 0, 0. So our new row 1 will become a third of the old row 1. Our new row 2 will become our old row 2 minus 2 our new row 1. Our new row 3 will become our old row 3 minus our new row 1. Our new row 4 will become our old row 4 plus 2 lots of our new row 1, and our new row 5 will become our old row 5 plus our new row 1. So that will give us 1 0 0 0 0 in that column, but now we need to perform those operations on the full row. After this iteration of the simplex algorithm, we still have a negative value in our objective row, and so we will pivot again. So we would choose that column with the negative value as our work column, and our pivot would be when we divide our left hand side by that column, which element gives us the least positive ratio. So 10 over 3 divided by 2 over 3 will give us 5. 25 over 3 divided by 5 over 3 is 5. 2 over 3 divided by 1 over 3 is 2. And so this will be our pivot. And we can decide on our row operations from here. So we're going to try and get our work column to be 0, 0, 1, 0, 0. So our new row 3 will be 3 times our old row 3. Our new row 1 will be our old row 1 minus 2 lots of our old row 3. We are able to use both our new and old row 3 for row operations because one is just a scalar multiple of the other. Our new row 2 will be our old row 2 minus 5 lots of the old row 3. Our new row 4 will be our old row 4 plus 5 lots of the old row 3. And our new row 5 will be our old row 5 plus the old row 3. So after performing those row operations, our objective row now has no negative values in it, and so we end phase 1. We will now begin phase 2. And for phase 2, we do not need phase 1's objective, and we do not need an artificial variable anymore. And now we will go back to our original objective, which was to maximize, and we will perform row operations based on that objective now. So we will look in our objective row, which is the original objective row, and we'll choose our work column as the most negative value, which will be here. And then we'll choose our pivot to be the element in that column when we divide the left hand side by that column that gives us the least positive ratio. So 2 over 3 or 5 over 9 or 2 over minus 4, which gives us something negative. So 5 over 9 is the smallest there. This becomes our pivot. Now we'll perform row operations, which turns this column into 0, 1, 0, 0. So our new row 2 will become a ninth of our old row 2. Our new row 1 will become our old row 1 minus 3 lots of the new row 2. Our new row 3 will become our old row 3 plus 4 lots of the new row 2. And our new row 4, which is our objective row, will become our old row 4 plus 10 lots of the new R2. Now to perform those row operations, and we we'll see there are no negative values in the objective row, and so we have completed phase 2. All that we need to do now is read off the solution. We read off the solution by setting all non-basic variables, so those with columns that do not just contain zeros and ones, as 0. So all our slack variables are 0. Slack variables of 0 mean that all our constraints are tight. And our basic variables, those with 1, 1 and the rest zeros in the columns, we can read off. We can say that x1 is going to be down to the 1 and across to the left hand side. So x1 is going to be equal to a third, x2 is going to be equal to 38 over 9, and x3 is going to be equal to 5 over 9. And that gives us a value for our objective. The best we can do is 140 over 9.